You got it. Starting left side, L1 power into my stop button, wire number 1. L1 power into my stop button, wire number 1. Out of my stop button into my float switch, wire number 2. Out of my stop button into my float switch, wire number 2. Out of my float switch into my start, wire number 3. Out of my float switch into my start, wire number 3. The N of my start is also the N of my memory circuit. So for timer T1, number 4. N of my start, N of my memory circuit for T1, wire number 4. This, if we're using 1 and 4, that would be 1, that would be 4. So T1, 1 and 3. Same point. So this way it disables the memory. This way it activates the next coil. So I don't need to go to here. What I do need to go to is down here, which would be wire 5. The memory circuit for my N2. So T1, 1. Right here to the T2, that's going to be wire 5. So if this is timer T2's number 1, that would make this a number 4, which would make this a number 1 with a number 3. That's number 1, that's number 1, you already have a wire here. So I need to jump down to the last memory circuit, wire number 6. So the N of my memory circuit for the chocolate pump is the N of my memory circuit for my agitator. So T2.
So those are both coming off of 1? Yeah.
Yes. So that would be wire number 6. Now I'm going to start working on this side of it. The out of my start goes to my motor starter coil, wire 7. The out of my start goes to my motor starter coil, wire number 7. I'm going to take my A1 from my motor starter also to my timer coil, number 8. So my A1 to my timer coil, number 8. Oops. Wire number 8. I'm going to come out of the normally closed set of contacts from timer T1 going into my memory circuit, wire number 9. T1 out of the memory circuit for my memory circuit, wire number 9, right? Yep.
Where is 8 at? I'm sorry, on that one right there.
Oh, coil to coil.
Okay.
So from the A1 to the 7 on our 8-pin relay for those timers that we're using in the shop.
And 9 is from T1 to M1, right?
Yep, that will feed your memory circuit, and then now we just have to seal it. So I will seal it. What's going to be the easiest way? It'll end up with, just because of just connecting the dots and trying to make it as clean as possible, I'm not going to just keep 2 under a screw, but in general, when we wire this up, just put no more than 2 wires under any of the terminals so you don't have stuff falling back out. So to try to make it a little bit clearer, I'm going to come from the motor coil to my memory circuit, number 10, to seal it. So from my coil to my memory circuit, wire number 10. I wouldn't do that when I really wire it, but just to try to show you how to connect all of the dots, this picture will be a little bit easier to see. What's starting the chocolate pump? From timer T1's open set, that's gonna be wire number 11. T1 memory circuit open set to fire the coil, wire number 11. I'm gonna do the same thing. M2's A1 coil to the timer T2's coil number 12. A1 from your motor starter to your timer coil, wire number 12.
And you're still gonna.
And that's what I'm gonna come back. So I'm gonna come out of timer 2's close set to feed my memory for M1. Out of timer 2's close set to feed my memory circuit, and what wire number? 13. I'm gonna hear these little numbers so it makes it easier to see. Go. And that's wire number 13. I'm gonna keep it close to seal my memory. I'm just gonna go right here again. So once again, just to connect the dots so I not have 65 wires hopping all over each other. Motor starter coil, seal the memory. Number 14. We drop back down to here. We're all the way down to this last portion. T2's open set is going to activate my motor starter. So that will be wire number 15. T2's open set. Activate my motor starter, wire 15. Motor starter coil to timer coil, number 16. Motor starter coil, timer coil, number 16. Come out of the closed of timer 3 to feed my memory, wire number 17. Out of the closed set from T3 to feed my memory circuit, number 17.
Pretty much repetitive, right?
Yeah.
Very much. That's what I want you to see is all the patterns, how everything's going to work over and over. And you seal it, and that would be wire number 18. Coil to memory seal, number 18. Now from there, the only thing we have to do left is all of the neutrals. Just remember, on the motor starter, this is your L2. It's going through a normally closed set of contacts to the coil. So on our the little motor starters we got next door, they're generally labeled 95 and 96. On some of the NEMA motor starters, you see where they're at on the very bottom. It just says NC for normally closed. What don't go off of just the numbers, look for the actual component, and if you're having trouble, look at how everything works. So for my L2, I'm going to go through my overloads to M1. So here's my L2, into the overloads, out of the lower overloads, up to A2. Do you want me to number these also?
Number what?
The neutral wires.
Yeah, please, yes, please.
Do you want me to do like A, B, C, D, so then we transition from numbers to letters for the neutral?
That'll be fine.
Okay. So my L2 into my overloads is A, out of my overloads to the coil is B. L2 into my overloads A, out of my overloads to the coil B.
And that's for all three, correct?
You're gonna do that on all three. I'll just go C, D, or whatever down through them. L2 come down, into the overloads, C, out of them, D. L2 come down, into the overloads, C, out of the overloads, D. L2 coming down, E and F. NE out F. L2 coming down. E F. Now, the T2 does not fool with any of the overloads. So where it's going in, the A, I'll just, what I'll do is a dashed line. So right here, I'm going to do a dashed line. So this would be G. So my dash line, so it's uninterrupted by the motor starter's overloads. G. N, so where the C comes down, H. Right here. H. And finally right here, from where the E goes in, where the E goes in the overloads, that way when you do this, you're not putting the timers neutral after the motor starter, but the motor starter would shut off and it would still go through its process. If you wanted it when the timer to shut off as soon as the motor starter shut off, then you would take it from right here. So it kind of depends on exactly how you want to define your process. And once you've defined the process, then you're just connecting the dots based upon how you know the theory to work. So right here, thoughts, questions, taking the written instructions, breaking it down to an input-output chart, developing our ladder logic, and then going over there and drawing all the wiring connections. Or is there any questions?
This can be wired a different way, correct?
Absolutely. This does not tell you how to wire it. This just shows you how all of the parts relate. And then once you know how they all relate, it's up to whoever designs it to draw either the wiring diagram or for us to troubleshoot it.
Does you feel like you, okay, so like, you feel like you can plug that in and work?
What do you, that?
Yeah.
Like that?
Plan on
Doing
doing
a
it.
diagram.
Yeah, I mean, I feel extremely confident in my work. I feel very good about it. It's just going through one step and just breaking it down. That's all it is. You develop what that system's going to be. Once you've defined what you want the process to do, break it into little chunks, draw your ladder. Once you've got your ladder, come up with your wiring diagram. Just break everything into littler pieces. Yes, sir.
So like you said that, you put the float switch in the, you drew them right between them, so it would look cleaner?
Right. Because it's right here between them when I put them on the board for the ladder. So then that way, you see how it's all jumping over as it is? I'm trying to make it as user-friendly as possible because I know looking at that picture, it's hard to see all these lines. They're not very large. So if someone wanted to, they'd have to pause the little video and blow it up to really see where all of them go. That's why I tried to do the neutrals with the letters of the alphabet, and then the dots, so then that way you know exactly what I'm trying to copy or represent from our ladder. And the more you do this, the easier it gets because you're gonna have more exposure to it. So the more systems you can go, oh, that's just like this. Then you just go back to what you know and how it was done, and then you're just basically regurgitating that information. Because the way I look at it, I don't care what your pump's turning. I really don't. If it's doing a pump and you're moving liquid, that's fine. If it's a conveyor and you're moving dry goods, that's fine. If you're mixing something, that's fine. It's still a motor. So it's gonna have overload, you're gonna have some form of a memory circuit built in if you're trying to keep that thing on. What you do with that component, that's on the process. But as long as I know how they're wired, how all of the parts work, then when I have to troubleshoot this, because in maintenance, that's what we're there for. We're there to fix whatever's broke or whatever's wore out or damaged. You know the theory part, and then you just come back. Why isn't this motor turning at the appropriate RPM? You go over and you listen to a motor that's single phasing, it puts off a pretty odd sound, and it's not moving at the right speed. The RPMs drop significantly. The current's gonna go back up tremendously. So now I can go over there. Why isn't this thing turning that RPM? Put a clamp around meter on it, see what's happening. Open it up, meg the motor. Figure out, do you have continuity through all three sets of the windings? And then all you're using your meter for is to verify what you know to be theoretically true. And if the theoretically what you know to be factually true is not what's displayed on your meter, you have to say why. And then you go through that process and figure out what it is. Getting to this is really going to help you when you start doing the PLC portion of it. Because you're taking a written set of instructions and then you're simply drawing it into the ladder. You don't have to do all of those connections because the timer is in the PLC. All of the connections are really coming through that. You just have to type in the logic portion of it. And those can be as involved or as easy as that process is for whatever you're going to produce. So you just want to be aware of that and make an educated decision.
We just had an incident at work, as a matter of fact, where on our last down day, they wired our blower fans backwards.
Oh, so the rotation was the wrong
Yeah.
direction.
So we couldn't figure out why we weren't pulling certain rooms down. We couldn't pull them down, and the machines were overheating. One of the guys that took a walk and went upstairs was just walking by it, and something just told him, we need to look at this. When they actually looked at it, it was going in reverse.
So it'd be blow of the air outside
It
air
was
back
blowing,
in,
but not
sucking,
out.
discharging the air out.
Instead.
So reversing the rotation on any three-phase motor, swapping two of the leads, and that'll reverse the rotation. If it's done through VFD connections, there is a little bit of additional programming that goes into it, because that has the ones we have a plus 24 volt DC signal that goes into the PLC, and then you're reversing it using that. But in general, if it was working fine, whoever wired it up just got the wires backwards. What a lot of people I found do is when something's not working, they automatically blame the PLC. It's the PLC's fault. If that piece of equipment's been running the last 5 years perfectly fine, so-and-so changed the motor and now it doesn't work, in my opinion, it makes no sense to us. It's the PLC program. Well, that person didn't do nothing to the PLC program and all they did was swap a motor and now it doesn't work. They messed up. It's just, you want to be very diligent, just knowing that how all the parts theoretically work, and then you're just trying to put something back to that set point. And as long as you take your time, break it down into little manageable pieces, it's not overwhelming. It's just when you look at something and it's got a ton of steps, it can get a little bit cumbersome. Just break it into, you do one little piece at a time. This step leads to this step, leads to this step. It's like that ancient saying, how do you eat an elephant? One bite at a time, right? So if you're taking this and you're going to do all of these, you're going to develop your ladder logic, you're going to develop your wiring diagram. You start here and you just systematically go through it one part at a time, look at it, and when I write my programs, I write it and I test it. Did it work the way I want it to? Because if I write a long program and it doesn't do what I want, now I got to really start to dive into, well, how far did it get down the program? If you do it in each little section, testing it, then you know after you did this step, and it goes, did it work? Yes or no? All right, perfect. Does it go to the next step? Yes or no? And that's how I do it. A little step at a time, then that way if I have to fix something, I don't have as much legwork to do trying to figure out what's working and what's not working. So that's how I try to do it. Any more thoughts, questions, wiring, written instructions, coming up with ladder going back to the wiring, how I kind of break them down? All right, can you stop that for us, please? And then I'll try to get those uploaded too, and then if you want to, absolutely wire it up in the shop.